Smari, welcome to the second of the Global Swadeshi Dialogs. Tell me who you are.
Well, I'm born in Iceland. I'm half Irish. I spent the first decade of my life living in England.
I'm
And
sorry.
after, what?
I'm
Oh,
sorry.
yeah. Yeah, it's terrible, isn't it? But after that, I moved to Iceland and onto this cluster of volcanic islands out in the middle of the North Atlantic Ocean. And I've been here on and off ever since. Um,
So you're some
so,
kind of seasteader, only it started kind of 1,000 years ago.
Yeah, well, I think the oldest part of this island is about 17,000 years old. So, yeah, but we've been growing it for a while. It
Yeah.
actually, we had this eruption on this island in 1973 that crushed about 3,000 houses and kind of messed things up a bit.
How
So,
when was the Westman Islands settled?
it was settled around 1870. No, 870. 800.
870. Okay.
Yeah,
So you've had settlement there for about 1,200 years,
yeah.
and it's about 5,000 people. Is that right?
Yeah, roughly.
Okay. And it's a little stone dot in the middle of the North Atlantic. How far from the Icelandic coast?
We're about 4 miles from the coast, but it takes about 3 hours by boat to get to the nearest harbour.
Gotcha. So it's really, I mean, it's not quite the ends of the earth, but it's pretty close.
Yeah. It's definitely one of the corners of the world.
Yes. Excellent, excellent. So anyway, so you're in the Westman Islands right now.
Yes.
Tell me what it is that you're doing.
Okay, so I'm currently working for the Icelandic Innovation Centre, trying to set up the first Icelandic Fab Lab. And I've been working on this for about a year. I got pulled into it, kicking and screaming about a year ago. It's funny actually how that happened was I had seen the TED Talk where Neil Gershenfeld is doing his explanation of what Fab Labs are, and I kind of watched it and ignored it for a couple of months. Then about almost exactly a year ago today, I suddenly remembered it, and I was sitting in an office just a couple of rooms away from here, and I thought, hang on, this might actually be a good idea. So I Googled it, I tried to find out what I could, found this email address, fired off an email saying just, hey, who are you, what are you doing, tell me more. 15 minutes later, I get this boilerplate wall of text describing the project, and at the bottom of it, there's this footnote saying, oh, by the way, we're having this conference in Norway on Tuesday. Do you want to come? And this is on a Friday, and I was going to do something insane anyway, so I bought a ticket, and that's kind of how I got involved with the Fab Lab project.
Yes.
After that, I went into the entire convincing people and raising funds gig, and a couple of trips to the States, and now we're almost ready to set things up. We're just sitting around waiting for the equipment to arrive, actually.
Wow. So you have the space, you've got an established area, you're going to put the Fab Lab, all that stuff is ready to go.
Well, we don't actually have the space yet. We're hoping that'll come through tomorrow.
Okay. So you're right in the middle of, you have the funding and you're just getting everything organised to put little boxes on the ground.
Exactly. It's actually it's in a mess at the moment, but that's the way it should be. It's fun that way.
Well, I mean, that's the way these things are when you're starting from scratch in such a short time.
Exactly. So, yeah.
So, what is a Fab Lab?
Well, it started off as this project in MIT where they thought, okay, we've got all this big government grant, but that means we have to do outreach. So they bought $50,000 worth of equipment and stuffed it into inner city Boston, where anybody could come and use the equipment. And it kind of exploded from there. The idea is make a laboratory where anybody can make anything.
Mm-hmm.
and it's like the prelude to molecular assembly in the home, where you'll have the Star Trek replicator or Stevensonian nanites, where you can build your own island and go seasetting on it, or just whatever sort of assembly you wish. So this is like in the middle. It's the bootstrapping phase.
So, I mean, let me put this into context. You've got $50,000 worth of tools, and that's little laser cutters and little robotic machine tools and things for casting plastics and things for making little circuit boards and electronic components and solderers. And I mean, I'm missing anything major there?
No, that's about it.
Okay.
All the equipment is, as far as we can, it's computer controlled.
Okay.
That being the innovation here. I mean, computer controlled CNC devices have been around since the 70s, but what's changed is now we can suddenly afford to put one in every town, every 4,000 person town in the world.
Yes.
And that's what's cool about this.
Yes.
So, and soon every school will be able to afford a Fab Lab, and making things for a one-man market will suddenly be possible and plausible.
So this is sort of like 21st century shop class, where you have a bunch of these serious machines that can make serious things. And I mean, we're talking about, you could go in here and you could basically build a transistor radio complete with the cool little waterproof plastic case and the knobs and all the rest of that.
Yeah.
That's sort of the level of complexity on that side of it.
Well, you can actually go one up on that and just build your own computer from scratch. I mean, it won't be a powerful Pentium-style machine, but it will do everything a computer is expected to do.
Yes.
There's plans to do environmental measurements, like doing humidity and temperature studies, networked devices for that.
Yes.
And the idea is you've got this Fab Lab network with 35 labs spread all over the world at the moment.
Oh, wait a minute, hang on. So there are 35 of these things?
35 is a rough estimate, and it's the closest to the real figure that I've been able to find.
Okay, and they're sort of dotted around... I mean, they're mostly in America. Where are they?
Yeah, there's 4 in South Africa. There's 1 in Ghana. There's 2 in Kenya, and then there's Boston, Chicago, San Diego. You've got all the usual suspects in there. You've even got 1 in Tokyo.
Wow.
There's 1 at the top of Norway, just at the northernmost part of Norway. There's 1 in rural India, and.
Wow.
They're setting up 1 in Afghanistan at the moment, in Jalalabad.
Oh, that's Dave Warner's thing, right?
Yes, Dave Warner, exactly.
Yeah.
And they're popping up all over the place.
Okay. So these little shops are all kind of much alike, right? It's the same roughly standard set of equipment in each shop?
Yeah,
so they've all got roughly the same capability to make objects?
Yes, and to a very large degree, the same equipment.
Okay.
There's been some change out, some replacements, but for the most part, it's every lab should be equivalent.
Okay, so theoretically, if you design something that can be manufactured in the Icelandic fab, you can send those designs across the fab in Cape Town or Soweto, and they can run off essentially the same object. Yes,
and actually we've got a Fab Lab-wide Git repository for designs.
Oh, that's interesting.
Yes.
Now, is that a recent thing?
No, it's been going on for at least a year.
Okay, so it's a distributed version control system for sets of plans which have been tested and can be made inside of a fab. And I mean, roughly how many things are in that repository?
Not that many. Unfortunately, there hasn't been that much useful stuff, but there are a few gems in amongst the empty folders. Stuff like a thinner client, which is a very small computer that you hook up to a television.
I saw pictures of these. They're like $10 or something like this, and
or even cheaper.
Wow.
Yeah, I think you should be able to do it for $5, but don't quote me on that.
Okay, but hang on a second. So you plug this thing into a computer, and into a television,
Yeah.
and it generates the appropriate signals to display like text on the screen.
Yeah.
Okay.
And it's just a text console, and it's like one of the old teletype terminals.
Okay, so it's like a dumb terminal for $5 that you plug into a TV set.
Yeah, and
Well,
that's great if you have a network.
Well, sure, but that in itself is really pretty significant.
Yeah. Then there's other things like.
I'm just imagining that a room full of those connected to like a Bluetooth hub that hanging off a telephone, acting as a relay to some cell tower or something. I mean, that right there is the kind of computing that you could do almost anywhere on Earth.
Rural mesh networks are definitely the thing of the future, and that. And carpeting their towns with wireless network is one of the things I'm very interested in.
Yeah.
There's been a lot of work been done in the Fab Labs over the last year on designing antennas.
Interesting.
Like making high gain, durable antennas out of glass and tinfoil.
Wow. Excellent. Well, anything involving glass and tinfoil.
Yeah, that's your specialty, isn't it?
Oh, absolutely. Well, in Afghanistan, they've been talking about having a solar cooker design competition. Where you can use the laser cutters on cardboard to produce precisely the shape that you want, and then cover the thing with tinfoil and then cook in it. Yeah. And you can do all manner of parabolics and non-imaging optics and all this kind of stuff. You can cut plastic and glass for enclosures to hold the heat. And there's all kinds of really amazing stuff that you can do if you've got the ability to take plans and just print them off on a device.
Yeah. So Fab Labs on the lowest level, you've got it used for innovation and seed companies, startups that want to take some design and manufacture it. And that in Cape Town, there's lots and lots of really good stuff going on with clothing designers and textiles manufacturing.
You can cut that stuff on the fab machines as well?
Yes, exactly.
Wow.
And wearable electronics are actually coming in strong. But
wow. From Cape Town?
I'm
just in general on the network?
In general.
Wow.
I mean, when I was in Chicago last August, there was talk about making a vest for biking that had like a stop sign on the back. That so if cars came within 10 meters of you, it would start blinking a stop sign with LEDs on your back.
Wow! So you'd actually have a detector that would point backwards, and it would be whoa.
It's very simple to make, and it's a couple of hours worth of effort, and then you've got a great safety device. And then if we move up one level past the novelty items, we've got important stuff like instrumentation for rural areas. In India, there's been a lot of work put into one of the problems they have there is when buying milk in the market, you never really know if the milk has been watered down or not.
Yes.
So the cream content of the milk is something that people want to measure. And simple instrumentation for that has been made in the Fab Lab. So basically you stick 2 wires into the milk and it'll give you a readout saying how much cream is in the milk.
Wow.
So that way you can gauge the pricing. And that kind of thing can lead to health benefits or whatnot. Moving even farther up, you can do hardcore science with this. And there we come into the entire environmental measuring system that I mentioned earlier. And a spin-off from that I've been considering is here in the Western Islands we have the biggest puffin colony in the world.
Yes.
It's about 4 million puffins.
That's a lot of puffins.
Yeah, it's quite a big colony.
Yeah,
but
I expect it's gotten a little bigger since people stopped eating them regularly.
Oh no, we still eat them.
Really?
And yeah,
man, puffin tastes bad.
No, puffin tastes brilliant.
I guess you evolved to like the taste of puffin. I think you must have evolved to like the taste of puffin. The one time I had it, oh man.
Where did you have it?
Someplace in Reykjavik.
Oh, yeah. See, people in Reykjavik don't know what to do with puffins. They don't know which way they turn.
So there are special puffin recipes of the Westman Islands, huh?
Well, generally, you want to smoke the puffin and serve it with mustard.
Okay, I'll give that a try when I get out there.
Just take my word for it. But okay,
Anyway.
So one of the things is the puffin colony has been going. It's been rapidly decreasing, and since it's 4 million puffins, and we only hunt about less than 100,000 a year.
Yes.
You know, it's hard to say that hunting is the main reason for this.
Sure.
So it's probably global warming or something related.
Some kind of general environmental effect.
Yeah. And their main feedstock is a type of fish that's not really found in copious quantities around the islands anymore.
Mm-hmm.
So one of the things I've been considering is using the Fab Lab to construct some sort of measurement devices to put in the puffin holes to measure humidity and comings and goings of the puffins.
Yes.
So that's something I've been trying to organize, but until I get the lab set up here, I can't actually move forward with that.
So, I mean, this is very interesting. What you're talking about here is the Fab Lab as an enabling technology for other projects.
Mm-hmm.
That you get into a situation where, it'd be great if I had a device that did X, Y, Z, and then you figure out roughly how to make it, knowing the capabilities of the lab. So you design to the capabilities of the fabrication technology you have, and then you turn out specifically the tool for the problem that you have.
Exactly.
I mean, what it gives me this image of is like, they talk about, utility trees where you have this kind of, fractal, manipulator.
Yeah.
That it's this thing of like industrial production produces these great big metal slabs, and the Fab Lab produces like this kind of adaptive tentacle that gets right down into your problem and solves exactly what you need to do. That It's a way of like pushing technology into the nooks and crannies of the problem.
Yeah, and you can think of it as a whole new tech tree, really. I mean, if you take Marchin's Open Farm Tech and you add a Fab Lab into that, then suddenly you have this this sort of set of technologies that first off do empowerment, which is always the first thing when you get a new technology. Then you have to educate the people around the technology. Then you start to build solutions to problems, and then you start getting markets.
Yes.
So, and of course, the market thing is something that a lot of people reel back in horror when they hear that. But it's actually an interesting facet of the entire thing, because once you have Fab Labs everywhere, the market is no longer centralized manufacturing and then you have global delivery, but rather you have centralized, to some extent, design.
Yes.
Then you ship the designs all over the place, and they get manufactured locally to whatever quantity is required.
So this is the sort of idea that your Nike, produces a sort of shoe template that you then ship out to the Fab Lab locally that will run you off a shoe configured to your foot from that basic sort of parameterized model.
Exactly. And if Nike wants a business model after 20 years, what they're going to have to do is stop selling shoes and start selling shoe designs that people can just print out in their homes.
Interesting. So, I mean, there's an implicit assumption here that in the same way that computers went from being... What's the name of the West Coast Computer Club where Jobs and Wozniak started? Homebrew, right? So you had Homebrew Computer Club where people made their own computers, and from that came the personal computer revolution. It sounds like what you're talking about is the anticipation of a similar phenomena for fabs.
Yeah, or rather, the Industrial Revolution got it half right. We're fixing what they got wrong.
Tell me more about that.
No, okay. Industry was never intended to be owned by huge conglomerates.
Okay.
What it was the first people who were introducing industry were people like Thomas Newcomen in the 1790s with, or actually no, early 1700s with the machine for raising water with fire, which was intended to pump water out of mine shafts.
Yes.
So it was the first steam engine. From there on, you have all sorts of minor breakthroughs leading up to the Industrial Revolution.
Yes.
And then suddenly, it's like the switch was flipped. And suddenly it wasn't just people, individuals building steam engines to solve problems, but rather it was people with lots and lots of money buying a whole set of steam engines and then using them to try and centralize the entire workforce.
Yes.
So what we're doing now is we're taking that back. We're decentralizing the workforce.
Decentralized industry.
Yeah, putting industry into the hands of the people, because that's where technology always belongs.
Interesting. So, desktop publishing, right, was an example of something where this already happened.
Yeah.
You got the laser printer, and rather than having $50,000 worth of Letraset kicking around, you walked in with your, RageMaker file and you printed off whatever it was, and there was your Canberra Ready Originals.
Yeah.
Similarly, laser printers initially were about $10,000, and now I think they've come down to about $120,000.
You know the story of how the bubble jet came into being?
No, I don't.
Okay, well, the thing is, laser printers were invented long before the bubble jet.
Yes.
But laser printers were expensive. And then there was somebody who said, hey, hang on, bubble jets could be neat. They could work. Designed a bubble jet. And I can't remember which company it was, but whoever owned the design or the innovation there, they said, wait, who would ever want a bubble jet? It's crappy quality. The ink smears. Count up all the faults of bubble jet ink technology, and nobody wants it. But they failed to factor in the small thing of price. The reason bubble jets got popular was because they were extremely cheap, and they were good enough.
Yes.
Yeah,
Absolutely.
So,
I mean, the worse is better thing is a pretty reliable rule. Yes.
Yeah. Okay. So the exact same thing. You have multi-million-dollar 3D printers today that aren't actually all that good. And then you've got Adrian Bowen's RepRap, which it's not fancy, it's not interesting for big companies, but it's good enough for home use.
So, just for context, tell me what the RepRap is.
Okay, the RepRap is a British design, British idea, and Adrian Bowens, who's working on that, he set off with the goal of, building a machine that can be volume bootstrap. That is to say, build a machine that is fully capable of self-replication.
Okay. And this thing is basically a 3D printer, right? You put goop into it, and it makes shapes in the goop.
Yeah.
And then you click the shapes together and add some other electronics, and it makes another one of these things which prints goop.
Exactly.
Right.
And you can make anything with it. You can, within the realm of what you can make by additive plastic placement. But the interesting thing about RepRap is that I just heard about it today. They have managed self-replication. It still needs some assembly, but they have managed to replicate a RepRap. So
it's a printer that prints printers.
Yes, exactly. And after they printed out the first copy, they made the copy, the child, generate a grandchild.
Wow.
So now, if you just put that into context, exponential growth here, say each printer only prints out 2 copies of itself.
Oh.
Then you have 2 to the power of n. That means after 10 iterations, you've got 1,024 of these devices.
Wow. Wow. So what we're talking about is like LAN parties where people bring their printers and print off more printers, and everybody goes home with an additional printer. Like all the people who came without a printer leave with a printer.
Yeah, and all you need is goop.
Yes. We must beware the patented goop barons.
Yeah, exactly. And of course, this is going to lead to a lot of grey goo once you get nanotech sorted out.
Well, I'm still.
Let's not worry about that just yet.
I was going to say I'm still skeptical about the thermodynamics of nanotech, but I mean, this is a pretty historic thing, right? Having a machine with which you can make copies of the machine. This is what Martin was talking about last week. Exactly. This idea that you've got a set of machine tools which can be applied to raw stock to produce more copies of those machine tools.
Yes, and the RepRap is a very unfancy version of this, but it works. That's the first step.
And and it's a big deal because it's like £300 or something. What's that? $400, £300?
Yeah, something like that.
Yeah,
$400 for a machine that is capable of breaking the volume barrier, which is once you've broken that barrier, you can essentially make anything.
Now, when you say volume barrier, you're talking about the price per unit for a small batch rather than a big batch of an object.
No, the theoretical barrier of what you can create, what you can make.
Oh, okay. Sorry, explain, please.
So making things always requires tools, right? So you get a tool that you get a spanner, and you can make anything that requires only a spanner to make.
Yes.
So if you get a tool that is capable of creating a perfect copy of itself, then that tool is capable of creating, where's the limit? That was one of the big questions that was laid forth in the 1950s, and nobody's been able to answer yet.
Right.
What's amazing is, as the more insane the idea, the easier it is to make.
Go on.
No, I'm going to let you extrapolate on that.
Well, I mean, in general, this comes from whole systems thinking, right? That it's much easier to get a large performance jump in a system than a small one. Because for the small performance jump, you take lots of little improvements, and for the big performance jump, you sit down and say, okay, what are we actually trying to do here? And then you find the simplest way of doing it.
And okay.
So I mean,
okay. Let's try attacking this from a different angle for a moment.
Yes.
Okay. What does this mean for personal freedoms?
No. Well, the ability to print my own shoes doesn't obviously immediately turn into more freedom.
Yes, exactly. The reason this is an interesting question is because in the 1980s, Richard Stallman asked, okay, why should people not have the ability to edit their own software?
Yes.
Fix software.
Yes.
Okay, the same applies. Why should I not be able to grow my own house?
Okay. So your VCR comes with some dumb set of restrictions that won't let you record what you want to record.
Yeah.
So you build another one that doesn't have those restrictions.
Mm-hmm. Or, even better, you decide that you want your VCR to also be a telephone. You add that functionality.
Right. So what we're talking about here is taking the commercial bottleneck away from hardware development.
Yes.
So I can finally get my little device that has an actual usable keyboard, but otherwise almost no computing power.
Yeah.
Like I want one, I build it. If you want one, I give you the plans, you build it.
Make your own. Or even better, go find some free hardware that somebody else has designed and download it and tailor it to your own needs.
So sort of cobbling together cobbling together consumer goods in the same way that we cobble together software.
Exactly.
You get a library, and it's the digital television library, and you plug that into your device, and now you've got a surfboard that watches digital television.
Yes.
Okay.
And of course, it's only a matter of time until somebody comes up with mashups for What is the Facebook of physical objects?
Oh. Okay.
So I think
Wow.
with regards to
Wow.
digital freedom, I say digital freedom. This is a term that I use a lot, meaning freedom applied to technology or anything that can be digitized.
So not freedom to show people the digit if you don't like what they're telling you to do.
Well, no, because freedom to or
Foundation for digital freedom, yes.
Yes.
So what we're talking about here is the scope of things that you're allowed to make, right?
Yeah.
When you say digital freedom, here's a file, it contains an object. If you produce this object, is the object legal or illegal?
Yeah. And why not make everything open and free so that everybody can just download and modify and remix their designs and
So we really are in sort of free as in freedom territory here.
Yes, definitely, because the entire goal of the FabLab project it came out of this lab called the Center for Bits and Atoms.
Mm-hmm.
The mandate of which is to bridge the gap between bits and atoms.
Yes.
And it makes sense. Why should digital reality be somehow different fundamentally from physical reality?
So free speech expressed as objects.
Yeah, why not?
You speak into a file, then you run the file and it's software, or you fab the file and it's hardware.
Exactly.
Oh Lord, this is going to get interesting, isn't it?
Oh yeah, and we haven't even gone into the entire, what happens when you start looking at the universe as a computer. What can it compute?
Yeah. So
the thing is, in this entire digital fabrication context, there's so much ground to cover, and so much of it is still within the realm of the impossible that, coherent discourse is almost impossible.
Right. And the whole thing has this kind of extropian shriek at the end of it. Wah!
Yeah, exactly. And, the best you can do is try and, lay it out in simple terms, point at good projects that have given good results, and, that's stuff like the RepRap and stuff like the textiles stuff in Cape Town.
Yes.
And you just keep pointing at that kind of stuff, and eventually you just hope that people will figure it out.
Right. So it's so you're talking about the small, simple, easy to understand stuff now, and pay no attention to David Dalrymple and what he's working on with this conformal computing business.
Exactly. Yes. Precisely.
Right. Pay no attention to Mr. Dalrymple.
Yeah. No.
Who
It's all part of the show. There's nothing to see here.
Right. So just to bust David on this, he's working on computers that you measure by volume. So you get 3 pints of a computer, and it's 5 times more powerful than a sixth of a pint.
Yes.
So it's computer goo that self-organizes to do your computations based on volume.
Exactly. Well, not necessarily based on volume, but one of the core concepts in this, as far as I understand it, is using cellular automata for distributed atomic scale computing.
Okay. Wait. So molecular scale connection machines.
What?
Like a molecular scale connection machine.
Yes.
So vast kind of bit plane processing with simple molecular steps.
Yeah. So think about, how can you calculate the exact value of pi using Lego bricks?
If you have a few 100 million Lego bricks, you can get pretty close. By drawing a circle and counting.
Yeah.
Yeah.
Or even better, what this essentially does, the stuff that David is working on, is it puts the entire programming thing, it takes it out of the text editor and puts it into the Paint program.
Okay, programmable matter.
Yes.
Yeah. Okay, so you have a bucket of goo. You take a piece of software, you drop the software on a chip, let's say, into the bucket of goo, and the bucket of goo grows into a sculpture that purifies the air around it.
Yeah.
I mean, straight down the line, implementation of nanoscale stuff, off in this direction.
Okay. The question here is, why is this important? And the answer is probably that if you look at how industry is done today, even in the Fab Labs, it's very brute force.
Sure.
You're using, you're using force to alter the atomic structure of things like metal.
Right,
and
right.
You alter it
blow torches, hacksaws.
Yeah.
I mean, real macro scale, machine tool force.
Yeah, and you use brute force long enough on a sheet of metal, and you might end up with a ship. But it's brute force. It's not the most elegant way to do it. It's not even a very good way of using the resources you have.
Mm-hmm.
Because not only are you wasting precious material, all the waste from the process, you're also wasting a lot of energy.
Yes.
So.
Yeah, like beating a curve into a piece of metal it's an intensive process.
Yeah. So what we should be doing is not so much using the hammer to build the ship, but rather convince nature to build the ship for us. And that comes into the line of looking at nature as a computer and trying to get it to compute to generate the objects we need.
Okay, just go there. Whoa, let me break that down here. So, I'm reminded of Richard Feynman's story where he's got a house full of ants, and what he starts doing is laying sugar trails, or he starts moving the ants out of his house so they lay a trail away from the house rather than towards it, or something.